This is Professor Rogers. In this presentation, I offer a short discussion of the structure of a hypothesis. If you're interested in research, this is a good thing to know. But I also have in mind the statistics final project that I assign in many of my classes. Because my classes are multidisciplinary, there's often confusion between the different disciplines about what a hypothesis actually is, and I address that here. In the scientific method, the hypothesis is the classic if-then statement, a simple conditional statement that specifies the relationship between the independent and dependent variables. For example, I might say, if X occurs, then Y also occurs. X is the independent variable. It is the condition. It's specified by the word if. Y is the dependent variable. It's the thing that's acted upon given the condition of the independent variable. As an example, to help us understand this, let's look at something from the social sciences. It's often conjectured that poverty and crime are related. The more poverty we have, the more crime we have. So I might write a statement like this. If the level of poverty is high, then crime is high. Poverty is the independent variable. Crime is the dependent variable. I'm a sociologist, and in the social sciences, we often incorporate variations in conditions as part of the hypothesis. These conditions are phrased to imply linearity or probability. So imagine us taking something like poverty and crime and putting the values of those two variables on a scatter plot and then drawing a line through the points to see the relationship. So that's why we have linearity or probability. When you see this in published research, it usually appears in the introduction or in the end of the literature review. So I have some examples before. The first two are in line with that scatter plot. As poverty increases, then crime increases. Crime increases as poverty increases. I might also want to talk about specific people. So you don't really have poverty levels among people, but when you look at a person compared to other people, they might be higher or lower on a scale of poverty. So for an individual, I might write the statement like this. As the likelihood of poverty increases, the likelihood of crime increases. There is a different approach to hypothesis testing that is very common, and it was developed by statistician Ron Fisher. This structure is often used in dissertations and theses, but it does not appear much in published research. When it does appear, it is usually placed in the methods section, not in the introduction or literature review. The idea of Fisher's approach is to have a null hypothesis and an alternative hypothesis. So we're testing whether or not we're going to accept or reject the null hypothesis. Now, if you're saying this sounds really familiar, remember that Fisher is a statistician and he's doing exactly what we are doing when we talk about statistical significance. So we're looking at whether or not something is inside or outside of the 95% confidence interval. If usually when we are looking for an association, most of our measures of association, the value of 0 indicates that there is no association. We often don't get 0. The question is whether or not 0 falls within that 95% confidence interval. If 0 does fall within the 95% confidence interval, we say that there is no relationship. If 0 falls outside of the 95% confidence interval, we say there is a relationship. Now, in terms of my poverty and crime example, I gave it to you here. So the null hypothesis, or what we might call H subscript 0, would state that there is no relationship between poverty and crime. So if my coefficient for the relationship between the two of those variables was in the 95% confidence interval of the coefficient, I would then accept the null hypothesis as true, that there is no relationship. The alternative hypothesis is H subscript 1, and that says there is a relationship between poverty and crime. Or in terms of our statistical example, it means that 0 falls outside of the 95% confidence interval of whatever coefficient I'm looking at. Now, it turns out this approach has generated some controversy, and it's not because of what Fisher intended. Fisher really did want us to think through the logic of statistical significance, but it has the effect of putting too much attention on statistical significance. So when I'm dealing with students, often they look only at the question of statistical significance, which is only one part of using statistics to establish inference. You'll notice with the social scientific variation of the if-then hypothesis, we have a sense of direction. So as x increases, y increases. That's a positive relationship when both values increase together. If x increases and y decreases, then we have what we call a negative relationship. So those who stick solely to Fisher's approach sometimes ignore the direction of the relationship, and they also ignore other things like the effect size or the goodness of fit of the model. When you're doing statistical analysis, you're supposed to be looking at all of these things and not just statistical significance. Some people have proposed variations to the Fisher hypothesis to accommodate the need to discuss direction better. So in example 1, you'll see that we now have the word positive appearing in our hypothesis. So we're bringing in the question of direction, and so we're going to say if it's not the direction we expect, then we would accept the null hypothesis, and if there is a direction there, based on our statistical analysis, we would accept the alternative hypothesis. In example 2, we're getting down to individual thresholds. Now, many students are going to be advised not to use these variations. Let me start with example 2, where there's widespread consensus about this. When we start specifying thresholds and having a value that's either above or below a specific threshold, that means we have to change our 95% confidence interval. Most statistics in our statistics packages assume that we're doing a two-tailed test for significance. But if we have a threshold against we're measuring everything, then we have to switch to a one-tailed test. And if our computer cannot do that adjustment in our software package, then we have to do the adjustment by hand. And most faculty advisors are going to tell you not to do that. The example number 1, there's some disagreement there. So some people will say that this is okay, that you can do a two-tailed test with this, implying that really the negative relationship can also be statistical significant. It's just not part of your hypothesis. But there are going to be people who say that example number 1 also implies a one-tailed test, and will therefore encourage you not to use example number 1 either. Okay, so you may be totally confused now, so I want to discuss the practical aspects about this, what to do. I do have a definite preference here, and it reflects my training. I prefer to see social scientific variations implying linearity or probability, and when I write something, I am writing a hypothesis-like statement either in the introduction of my paper or towards the end of the literature review. But I also am a realist, especially because I teach multidisciplinary classes. There are dissertation and thesis advisors and departments that have specific standards, and they may specify the Fisher approach to hypothesis testing in a dissertation or thesis. And if you are in that situation, I would say follow the rules of your department. Now, in my final projects, I often ask for the student to write the hypothesis out. And I am clearly aware of this disagreement about how a hypothesis should be structured. So you can write your hypothesis any way you choose to fit. As long as you're following the rules of your department, I will be fine. Think of me as being bilingual and being able to understand each way of approaching this question. I do want to point out, though, that when you're talking to people outside of the data analysis aspect of your project, they're really interested in hearing about direction. So there is a way to incorporate social scientific variations into a dissertation or thesis in a way that will not offend most advisors and departments. You can still have a statement of direction in the introduction or in the literature review, even if you have that Fisher-like statement in the methods section.